Today we're going to program the last bit of our player logic. In particular, we're going to use collision detection, which is an essential concept in game development, to trigger the death event of our player and then respawn him to the beginning of the scene. And also, we'll restrict his left and right turns to only when he's running on a corner segment, like the actual TempleRun game. So let's proceed. First, let's explain what collision detection is and why it's essential in game development. If you think about it, our player game object collides with all sorts of game objects in the game using his character controller capsule. For example, he is able to run on the bridge segment's prefabs because his character controller capsule is colliding with the bridge segment's box colliders real time. So if we go ahead and turn off the box collider component of this segment prefab, then the player's character controller capsule is unable to detect its presence in the game and hence will pass right through it. Now oftentimes it's necessary to know if specific collisions have happened in the game between certain game objects. For instance, if the player collides with an obstacle segment, then he should die, but if he collides with a coin game object, then he should collect it, and so on. Likewise, if the player character control capsule is colliding with a corner segment, then and only then should the player be able to turn either left or right, depending on if it's a left corner or a right corner segment. And the easiest way to detect specific collisions in Unity is through tags. We're basically going to tag some game objects with designated tags and then go to the player controller script and check if the player's character control capsule has collided with them or not by referencing these game objects using their designated tags. So let's add a few tags. Select any game object from the hierarchy. I'll select the player game object, doesn't really matter. And then go to tag from the inspector window, select add tag. Click the plus sign under the tags option to add a new tag. We'll call the first tag R corner. And we'll use this tag as a marker that's going to let us know if the player has collided with the right corner segment game object or not. Hit save. Let's add a second tag and call it L corner. And I think you know what this tag is going to be used for. It's going to be used to detect collisions with the left corner segment's game objects. And finally, let's add a third tag and call it obstacle, which is going to be used to detect collisions with all the game objects that are going to cause the player to die in the game. Now let's go to the prefabs folder and start assigning tags to specific game objects. Locate the I_jump_obstacle prefab, double click it so that we can edit it. Click on the right arrow to expand its children game objects. And let's expand its jump_obstacle game object and select its children game object called sidewall. Let's adjust the view so that we can see it better in the scene window. Here it is being highlighted in the scene. Tag it as obstacle, click on the return arrow, double click on the I_slide_obstacle prefab, select the slide_obstacle game object and expand its children game objects. Tag each of them as obstacles as well. There are 9 in total. Return, double click on the right corner bridge prefab, and here are the different pieces making up the entire right corner bridge segment shown as game objects. We want to select the game object named corner 2, and you can see it being highlighted in the scene. Let's tag it as R corner because we want our player to be able to turn right only when he steps on this piece. Now if the player hits this sidewall, then he should die. So select its game object either from within the scene like so, using the move tool, or select it from the game object hierarchy, which is named sidewall_L_3. And let's tag it as obstacle. Finally, we want to prevent the player from jumping off this sidewall. So let's adjust the boundaries of its box collider by clicking on this icon. And now we can see the boundaries of this sidewall game object's box collider with a dot on each of its sides. These dots can be dragged outward or inward to adjust the boundaries of this game object's box collider. Let's drag it upward from this point, like so. This looks good. Now the player won't be able to jump off this sidewall because he's gonna collide with this invisible wall. Let's go back to the scene and repeat the same steps for the left corner bridge segment prefab, only this time we'll use the L corner tag. Select the corner 2 game object of the left corner bridge prefab and tag it as L corner. Now select the sidewall_R_3 game object and tag it as obstacle. Finally, adjust its box collider boundaries by making it vertically higher to prevent the player from jumping off of it. Now we're ready to script the collision-based behavior for our player, like restricting his left and right turns as well as his death event. So let's go to the script folder and open up the player controller script. First, we're going to create a variable of type bool and call it canTurnRight, and then initialize it to false. This is called a boolean variable and it has 2 possible values, true or false. We're going to use it to store the player's collision state with the right corner segment. True if he's colliding with the right corner bridge segment and false otherwise. And let's create another bool variable that's going to let us know the player's collision state with the left corner bridge segment, and we'll call it canTurnLeft and initialize it to false as well. Now we want to be able to access the player's character control capsule collider here in the script so that we can change the values of these two bools to true if the player collides with either a left corner or a right corner segment in the game. And the only way to do that is by calling the onControllerColliderHead function, which is a predefined function in Unity. So let's go to this line and call that function. This function is gonna get called every time the player's character controller capsule collides with a game object in the game. And we must pass a controller collider head variable as its parameter, which we will call head. This variable here stores the collision information of the player's character controller capsule collider, which will enable us to extract all sorts of useful information about specific collisions from it. So now we write an if statement that checks if the player's character controller capsule collider has collided with any game object in the game that has the tag lcorner. So type head dot game object dot tag double equal signs, a pair of quotation marks, lcorner. So this statement here means in C#, if the player's character controller capsule collider, which is referenced by this head variable, if it collides with a game object that has the tag lcorner, then set the content left variable to true. And remember that this tag is used for the left corner segment prefabs or game objects, and it's case sensitive. So now we have a way of knowing if the player's game object has collided with a left corner segment using this variable. Okay, else if the player's character control capsule collider collides with a game object in the game that has the tag rcorner, and these game objects are gonna be the right corner segment's game objects, in which case change the value of the content right variable to true. And finally, let's keep the content left and content right variables as false, because in that case the player will be colliding with other game objects that don't have either of these tags. And now we have a way of restricting the player's left and right turns to only when he's running on a corner segment. So let's go to the player logic function and make the if statement that checks for the user's G key press also checks for the content right bool. So now we've conditioned the player's right turn movement to when the user presses the G key and when the player is running on a right corner segment, which is when the value of this bool is true. If these two conditions are both true at the same time, then the player should be able to turn right in the game. Otherwise, the player won't be able to turn right. And now we'll do a similar thing for the left turn movement. We'll make the if statement that checks for the user's F key press check for the state of the content left bool as well. And now we're ready to test the newly programmed behavior for player in the editor. So save the changes and go back to the editor. Let's hit play, and the keyboard's keystrokes will be displayed on the screen. And now if I hit either the F or G keys, it will have no effect on the player's movement because he's not running on a corner segment. And if I hit the G key on the right corner segment, then he turns to the right. And if I hit a G key on a left corner segment, then nothing happens, which is what we want. And if I hit the F key as the player is running on a left corner segment, then he turns left exactly as we want him to. Okay, now let's see if he can jump off a corner side wall. Here is a left corner segment, works great. And here's a right corner segment, looks good. So it seems like everything we programmed works exactly as intended, which is nice. Now let's go to the player control script and work on the player's death behavior. The first thing we need to do is create a bool that's gonna let us know if the player has died in the game or not. Let's call it isDead and initialize it to false. So if this bool is false, then the player is considered to be alive. And if it's true, then the player is considered to be dead in the game. Now the player dies in the game if he collides with any game object that is tagged as obstacle. We have established that in the beginning of this tutorial. So let's go to the onControllerColliderHead function and write an if statement that checks if the player's character control capsule collider has collided with any game objects that we have tagged as obstacle. If that happens, then change the isDead bool to true, so that we know that the player has died in the game. And also, play the tripping animation. So we'll set its trigger here. Now once the player dies, the entire game should freeze after the tripping animation is finished playing. So let's go to the player logic function up here and write an if statement at the beginning that checks if the player is dead or not in the game by evaluating the isDead bool. If this isDead bool is true, then exit the player logic function, which is what this return keyword means in C#. So if the player is dead in the game, then do not go about executing the rest of the code in this function. Let's save the changes to our script and see what we have programmed in the editor. Let's play the game. Here's an obstacle. Oh wow, that's strange. I mean, the player has tripped and the game has frozen once he collided with a game object tagged as obstacle. But the animation looks a bit off. So let's locate the trip animation in our project's assets folder and bake it into position just like we did with the previous animations. Tick this box, choose original, tick this box, and this as well. Hit apply. Now let's play our game. Okay, much better. And if we press any key, then nothing happens. And also, the player's movement has come to a full stop. This is because the player logic function keeps exiting since the isDead variable is now set to true. Let's test the collisions with the other obstacles. Here's the jump obstacle, and the player trips and stops when he collides with it. Now let's look for a slide obstacle and see what happens when the player collides with it. He dies as we programmed him to. Now what we want to do is prompt a graphical user interface or GUI on the screen once the player dies that has a respawn button that's going to enable the user to play the game from the start if he clicks it. So let's go to the player control script and make a simple GUI button. The predefined function in Unity that is in charge of handling GUI events in the game is the onGUI function. So let's call it here. And we want the GUI button to appear only when the player dies in the game. So let's write an if statement that checks for that here. Now what we're gonna do is create what is known as an immediate GUI until we create our own professional game menus in a few tutorials. So our button won't look very pretty now, but we're using it as a quick way to develop our game. This immediate GUI system is very handy when developing games in Unity, so it's best to familiarize yourself with it. So type if, open a pair of parentheses, GUI, dot button, open a pair of parentheses, type, new rect, open a pair of parentheses. So now what goes inside these parentheses are the attributes of our button, like where it should appear on the screen and how wide or long it should be. But let's specify these attributes in a bit. Put a comma, and then let's write a string text. So put a pair of quotation marks, and we're gonna call our button respawn, all capital. Now let's go to the new rect function and tell Unity where to draw this respawn button in our game. The first argument of this function is the x coordinate of the button's position on the screen. And it starts from the upper left corner, not the center of the screen. So 0, 0 is the upper left corner of the screen. We want our button's horizontal position to be 40% of the screen's width. So it's a little bit to the left. Type 0.4 times screen.width. Put a comma. Now the second argument is the y position of our button on the screen. We want it to be 60% down the screen's height. So it's gonna be a little bit below the center of the screen. Type 0.6 times screen.height. Now the third argument of this function, separated by a comma of course, is the button's dimensional width, which we want to be 20% of the screen's width. Finally, the last argument is the button's dimensional height, which we're gonna make 10% of this screen's height. For some reason, Visual Studio is showing us that there is an error in this line. Oh, I see, we have double parentheses here. Now this screen class in Unity gives us access to the user's screen resolution on whichever device screen he is running this game on, be it a computer monitor or a mobile phone screen. And we're using it to scale our button proportionally to fit every possible screen with any resolution. Now once the user hits the respawn button, we want to reset everything in the game back to its initial state or value, as if the user has just started playing the game. And we want to do all of that inside a function that we have not yet created called deathEvent. And it looks like we forgot to close the parentheses for the if statement here. Now let's go down below and create the deathEvent function, and it's of type void of course. Now the first thing we need to reset once the user chooses to respawn the game is the player's position in the game. So let's reset him back to his initial position from when the game started, which is 0, 0, 0. Now because we're adjusting the player's position in the game manually in this line, we could run into some problems because Unity uses the character controller to move this game object around, which is the player's game object of course. So let's turn off the player's character controller component temporarily before we reset his position manually in the game. Type c character controller dot enabled equals false, semicolon. And we're gonna re-enable it here in the player logic function after we made sure that our player is not dead. So this statement says, if the player's character controller is not enabled, then go ahead and enable it. And we said in a previous tutorial that this exclamation point means not in C#. Now let's go back to resetting the values of the other variables. The player's rotation needs to be reset back to 0, 0, 0. And also let's reset the player direction variable back to north because it's his default direction when the game starts. And the same goes for the player next direction variable. Let's see, what else needs to be reset? Yeah, the player speed needs to go back to the player start speed, so any increment in speed that the player may have picked up before his death is gonna be wiped clean. And the player vector variable needs to be reset to the forward vector times the player speed times time dot delta time, which is the same value as when the game first started if you remember. Now let's save the changes to our script and see the player's no death behavior in the editor. Hit play. If we hit an obstacle in the game, then the player trips, the game freezes, and a respawn button pops on the screen. Now what we need to do is destroy the spawned bridge segments that are ahead of the player from before his death, because once the user hits the respawn button, we're not gonna have any use for them in the game, so they must be destroyed from the game. And also, we need to reset the spawn coordinates as well as the segment spawn direction every time the user chooses to respawn the game, so that we could spawn the segments from the start correctly. So let's go to the bridge spawner script and do that. Let's create a public void function here and call it clean the scene. And we're making it public because we're planning on using it from inside the player controller script. The first thing we need to do here is destroy every game object that's stored in the active segments list from the game, which, if you remember, the active segments list is what allows us to keep track of the spawned segments game objects in the game. Then we need to remove these game objects from the list because we're not gonna need them. We'll be starting fresh instead. So let me show you how we can clean a list variable in C# from all of its elements. We're gonna use a for loop to accomplish that. It's gonna look like I'm doing something that I can't explain, but bear with me and type the following. For, open a pair of parentheses, and j equals active segments dot count -1 semicolon is bigger than or equals 0 semicolon j minus minus. A pair of curly brackets, destroy, open a pair of parentheses, active segments, a pair of curly brackets, j, semicolon. New line, active segments, dot remove at, a pair of parentheses, j, semicolon. Now this block of code here is one way of how we can remove every element in a list in C#. Its explanation is a little tedious and might be out of the scope for this course, so we'll skip it. I might add a document in the resource tab that goes over how this block of code works piece by piece if enough of you are interested, but for now we'll take it that this is how you clean a list from its elements. Now after we've destroyed all the spawned segments in the game from before the player's death, and also we've cleaned our active segments list so it has 0 elements now, we must now reset the spawn code variable back to its initial value, which was 00-6 if you recall. And also we need to reset the secCurrent direction variable back to north, and the same goes for the secNext direction variable. And finally, we need to call the initialize segments function so that it can spawn a few regular eye-shaped bridge segments ahead of the player when the player is respawned in the game. Now we have no way of knowing if the player has died in the game here in the script, unlike the player controller script where the isDead boolean lets us know the player's death state in the game. And we want to know the player's death state here in the bridge spawner script because if he's dead, then we need to turn off the play trigger function. Otherwise, it's gonna cause all sorts of problems for us when we hit the respawn button. So let's create a bool here, which we will call stop game, and initialize it to false. And let's go to the player trigger function and deactivate it if this stop game bool is true. Now let's go to the clean the scene function and set the stop game bool true first thing, and then set it back to false last thing. Now because this function is going to be called from inside the death event function, and the death event function will not be called unless the player is dead in the game, we have effectively deactivated the player trigger function from executing when the player dies in the game, which is what we want. Also, because we've made this function public, we can invoke it from outside the script. So let's go to the player controller script and reference the bridge spawner script from a variable called b bridge spawner. If you have a different name for your script, then be sure to reference it using the same name. Mine is called Big B Bridge Spawner. Now let's go to the start function and set it to an instance of the bridge spawner script, b bridge spawner equals. Let's find the game object that the bridge spawner script is attached to, which is the bridge manager game object. Type game object dot find, open a pair of parentheses, a pair of quotation marks. Let's put the name of the game object that we're looking for, which is bridge manager, and then get its bridge spawner component. Now you may have attached your bridge spawner script to a game object with a different name. If that's the case, then be sure to look for the game object using its name and then get its bridge spawner component. My bridge spawner script is attached to the bridge manager game object. This is yet a third way of accessing other game objects components. We saw the first way in the CamLogic script where we were able to access the transform component of the player's game object from the CamLogic script, which is attached to the main camera game object, by declaring a public transform variable and then dragging the player's transform onto it in the editor. In the second way, we use the player tag to access the values of his transform component from the bridge spawner script, which is attached to the bridge manager game object. The third way is the one we've just seen in the player controller script, which is to look for the game object of interest using its name and then get the component that we want from it. It's really important that you know the different ways we can use Unity to make different game objects communicate and interact with each other. It makes the development process much easier. Now let's go to the death event function and invoke the clean the scene function using the b bridge spawner variable. Let's call the clean the scene function from the b bridge spawner object. Let me just make one quick remark about calling functions this way, i.e. from another script. From the player control script's point of view, it does not know how this clean the scene function is implemented in the bridge spawner script. It can only interface with it using the small b bridge spawner object, which is an instance of the bridge spawner class. And that's good practice because we do not want to edit the code of one script from another, as this would make the chance of us making a huge error in the code much higher. Instead, we want to be able to use functions or methods as well as variables or members defined in a class, but make sure that their code is protected from any adjustments so that we do not make catastrophic programming error. If you want to make a change to the method of a class, then we need to go to the source code of that class and adjust it from there. Now, this style of programming is formally called object-oriented programming, and it allows us to make really modular and reusable code. And we talked about that in past tutorials. We have one script which Unity treats as a class in charge of implementing the player logic in the game. We have another script in charge of spawning our bridge segments in the game. And we can interface between the scripts or classes to access something specific in any of them. This makes the development process much easier and less prone to error by us, the developers. Sorry if I'm explaining things in too much details, but you're seeing a fine example of how object-oriented programming is being implemented. If you take an academic course, you may not develop the intuition of thinking in terms of objects and classes until much later. But here, you're literally seeing how a variable or an object could be used to start a bridge segment that can then be spawned and destroyed in the game. Okay, let's do one final thing in our death event function, which is to set the spawn trigger that makes our player's animator controller transition from the trip animation to the running animation. And yeah, one more thing, we need to change the player's death state to alive by making the isDead variable false. And lastly, we'll go to the player logic function and set the death condition for when the player falls off a bridge segment. If the player's Y position is less than minus 0.5 units in the vertical direction, then change his death state to true and play the trip animation. This should be less than. Save the changes to both script and go back to the editor. Let's hit play. Once we hit an obstacle and click the respawn button. Oops, what happened? Let's play from the start. And if the player falls, then he dies, so that's working properly. But when we respawn, the segments are not regular eye-shaped segments, even though we're calling the initialize segments function from inside the clean the scene function. Let's go back to the bridge spawner script and see what we can do to fix this. Oh, I see. We need to reinitialize the small s segment object by calling its default constructor before we call the initialize segments function. You can see that we are almost relearning our code by making these mistakes, which is a good thing. Save and go back to the editor, hit play. And now if we die and respawn, we can see that everything gets reset to its initial state. With that comes the end of this tutorial, and the completion of the player logic in the game. We've come a long way from just propelling him forward. Our player can now pick up speed as he runs and receives input from the user. He can also turn and jump as well as collide with all sorts of game objects in the game. He also has many different animations and can die and be respawned in the game. And we were able to achieve all of this in less than 200 lines of code. I guarantee you that you cannot find something like this elsewhere on the web. People are using 200 lines of code to get a ball rolling, and then they call it a game, and worst of all, they call themselves developers. But I told you this course is very different from the others. In the next tutorial, we'll add sound effects to our game, because a game without sound is not a game. See you soon.